So in today's video, we're going to be making superpowers in Roblox. I got this idea in my last video when we used linear velocity to create propulsion using a rocket launcher. And it got me thinking, what if we apply linear velocity to every part in the workspace? And to activate it, the player must press a button. And when they stop pressing the button, it gets rid of linear velocity, giving the player this ultimate power. So that's what we're going to do today. I'm going to show you the power of using linear velocity. So let's jump right in. The first thing we got to do is, well, since this is a basic base plate, let's go ahead and start adding some random parts in the workspace. So I'm going to do that real quick and I'll be back here in a second. All right. I have some random parts in the workspace. We need to go through and get rid of all the welds. I mean, we can get rid of the welds inside the script, but it'll just be easier if we just go through each part and just get rid of all the welds. So let's do that now. And we're also going to need to make all these parts anchored just so they don't move um, right at the start. So let's go ahead and select all these and let's anchor them. Now, we're also going to need a rig, not for anything in particular, except for testing if we can lift up, um, things with humanoids, but mostly just to kind of give an example of what we're going to be using. We're going to need the root attachment inside the humanoid root part. Um, because what I'm thinking is when the player presses E, I also want to lift the player up itself, but keep the player floating. So we're going to be using align position combined with linear velocity, and both those things uses attachments. So for align position, we're going to be using this root attachment to attach it to. So I'm also just going to keep this here just for spelling purposes, because you have to make sure everything's spelled correctly. But I'm also going to duplicate a couple of these just for testing purposes as well. All right. So now we can go ahead and start scripting. And I think the first thing what we're going to do is script the user inputs. And we're going to go inside starter player and inside starter player scripts and just put in a local script. Um, we'll grab the player game dot players dot local player, and we'll grab user input service game colon get service user input service. I'm also thinking about adding a flag, so local is active equals true. We're going to be using this flag just to see if the button is being held or not. So now we can grab our input begin, connect function, and then we can say if input dot keycode equals enum dot keycode. We'll say E. Then we'll say is active equals true. And then we will add event here. Now we're going to need something for when the input has ended. So basically the same thing as above. Input ended, connect function. Then we can say if input dot keycode equals enum dot keycode e, then we can say is active equals false, and then we can add event. And that's basically it. We just need to make some events. So we'll go inside replicated storage because this is going to be this power can be used multiple times. So we want to replicate it. So we're just going to add 2 remote events. We'll call this start power and rename this to stop power. Simple enough. And then now we just plug them into here. We can say game replicated storage stop power fire server, because we're going to be sending this information to the server. We'll put in the player. We can say game replicated storage stop power fire server. Plug in the player, and that should be it. Now we can kind of do the main part of the scripting, and to do that, we are going to be going inside server script service. We're going to put in a server script, and we're going to need a couple things. So basically, we need to get everything inside the workspace. So anything inside this workspace, we are going to be applying linear velocity to. So I'm just going to go ahead and grab workspace. It will just be a little bit faster. Get service workspace. We're also going to need to grab the floor or whatever floor we're using. In this case, we're using base plate. We don't want to apply anything to base plate. So equals workspace dot base plate, or else it'll apply linear velocity to base plate, and then base plate will be flying everywhere, and that's not good. So whatever floor you're using, make sure you get it, and I'll show you where I'm going to be putting base plate so it doesn't apply linear velocity. Now we're going to need a couple settings because I want these parts to kind of orbit around the player. So we're going to say local orbit radius. We'll make that equal to 40. We're going to be using orbit radius to kind of judge the distance between the player and the part, because we don't want the parts to come smashing into the player, um, or else the player will just ragdoll. So we need kind of like a buffer zone. We're also going to need a pull speed, and we'll make that equal to 10. And then we're going to need a lift speed, and we'll make that equal to 15. We're also going to need a float height for the player. We'll make that equal to 40. I think 40 studs high is that should be high enough. I mean, we can always go higher. I'm creating these settings so if you are using this, all you got to do is just change these settings um to kind of play around with it instead of like inside the core of the script, so to speak. We're also going to need an orbit speed. Orbit speed. We'll make that equal to 30. And then we're also going to need a float force, which is actually going to be quite a bit. We'll make it 50,000. Um, so we're going to need some sort of force to lift the player. So 50,000. Hopefully that's enough. Honestly, let's try 5,000 just in case. And I think that should be it for the settings. We can go ahead and start creating our function, local function. Um, we'll just call it superpower. And we'll plug in our player. All right, so the first thing we're going to need inside this function is we need to grab our character. We need to grab our humanoid root part. And then we'll add some checks for that. And then we will apply align position. We'll create it, apply it to the player. So let's go ahead and grab our character, and we'll make that equal to player.character. And then we could say if not character, then return end. And now we're going to need our root. We'll make that equal to, character. Find first child, humanoid, root part. And then we could say if not root, then return end. And that should be it for our checks. Now we need to grab the root attachment from the humanoid root part. So we can say local root attachment equals root find first child root attachment. Make sure that's spelled correctly. All right. So now we can start. Now that we have the character, we have the humanoid root part, and now we have the root attachment. Now we can use this align position equals instance new align position. And being that align position uses attachments, we could say align position dot attachment 0 equals root attachment. And then we could say align position dot mode equals enum dot position align mode dot one attachment, because we're only using the one attachment, which is going to be to the player. Align position dot max force is going to be equal to our float force. And then align position dot responsiveness, we're going to make that equal to 10. And then we can say align position dot position is going to be equal to our root dot position. And then we're going to add a vector3 dot new. And then we're going to say 0 on the x, and then we're going to add our float height on the y, add a 0 on the z. Then we can say align position dot parent equals the root. And basically this should work. We could test this out. We could just plug in our event. So game.replicated storage, start power, on server event, connect. And we'll just plug in our superpower. And let's test this out. All right, so all I have to do is just press E. It's not lifting us up just yet. I have to jump, so we're not getting enough force. Let's try 50,000. And yeah, it works. So if we go inside here, we find our player. We go inside the humanoid root part. You can see that it is applying align position. And yeah, we got it to work. Now we can plug in the stop power, but we'll wait on that because we'll make a separate function for that. We can now start applying linear velocity to all the parts in the workspace. And to do that, we have to make a loop. So we'll say for underscore comma. We'll call everything part in pairs. And then we can say workspace colon get descendants because we're going to get everything. Do. And then we can say if part colon is a base part and part doesn't equal base plate because we don't want this to apply to base plate and not part colon is descendant of character then because we don't want it to apply to our player as well. I guess the first thing we got to do is make sure all the parts are not anchored. Part.anchored equals false. Now, linear velocity requires an attachment. So we have to make an attachment for all the parts. So we're just going to say local attachment. We're just going to make a new instance equals instance.new attachment. And actually, we will plug in our part here. So it applies to the part. And then we could say attachment.name equals orbit. We're just going to name the attachment. So the thing is with linear velocity and attachments, and since we're looping, it's going to be creating new attachments and then creating new linear velocity. We're going to have to destroy all those when we want everything to stop. So just by naming it orbit, it'll just be easier to just destroy it. I could just say destroy orbit, you know? So it's just a little bit cleaner. And now we can get linear velocity. Local linear velocity equals instance.new linear velocity. And then, like I said, this uses attachment, so we can say linear velocity dot attachment 0 equals attachment. Then we can say linear velocity dot max force equals math.huge. This gives it unlimited force to any object. Then we can say linear velocity dot velocity constraint mode equals enum dot velocity constraint mode dot vector. Now this should be like linear velocity in the documentation in on Roblox. Pretty sure it makes vector the default, but just in case, we're just gonna set it here so there's no like conflicts. Now we can say linear velocity dot parent, and we're gonna make that equal to part. So basically, this is just gonna create linear velocity, attach it to the attachment, and it's gonna parent all of this to the part. Very simple. We're also gonna be we should probably make a flag actually. Say local is active equals false. Now we're going to be putting in a task.spawn function. There's some space here. And then we're going to say is active equals true. Then we can say we're going to make a like kind of a while true do statement here. We're going to say while is active. in part dot parent in character dot parent do. Okay, so there's a couple things we're gonna need. We're gonna need the part position, player position, and the direction that we need. So let's grab our part position, and that's just going to be equal to part dot position. And then we're going to need our player position, and we're going to need our player dot character dot humanoid root part dot position, and then we're going to need a direction, and we'll make that equal to player position minus part position, and we'll make that equal to dot unit. Now we're also going to need an offset. So local offset equals part dot position minus our player position dot unit, actually dot magnitude. Now we could say if offset is greater than our orbit radius, then we could say direction equals direction, and then we can multiply that by our offset minus our orbit radius, and that should be it for that. Down here, now we're going to need a orbit direction and an orbit velocity. So we'll say local orbit direction, and we'll make that equal to vector3.new, and we'll say minus direction.z. We'll make the y 0, and then we'll say direction dot x unit, and then we'll make an orbit velocity, and we'll make that equal to orbit direction, and then we will multiply that by our orbit speed. And then we can now apply linear velocity dot vector velocity, and we will make that equal to our direction times our full speed, and then we can add a vector 3.new, and we can say 0 lift speed 0, and then we can add our orbit velocity. And being that this is a while true do statement, basically we have to add a task.wait so it doesn't time out. So we'll say task.wait, and we'll say 0.1. All right, that is pretty much it for linear velocity, putting it on the parts, and then making the parts orbit around the player or wherever the player is. So now we can go ahead and make a stop function. We can say local function stop power, And we can plug in our player. And it's going to basically follow the same concepts as above. So we'll go ahead and just copy and paste all this here. Now we kind of have to loop through the all the parts again, destroy the attachment, and destroy the linear velocity. We also need to destroy a line position for the player, so we should probably do that first for the player. So we can say if root find first child. We say align position. Then root dot align position destroy, and that should do that. We also need to make sure is active equals false. Now we can loop through again because call them part in pairs workspace get descendants do. You say if part is a base part and part doesn't equal base plate and not part is descendant of character. Then we could say if part find first child linear velocity. Then we could say part dot linear velocity destroy. And then we could come down here and say if part find first child orbit. Then part dot orbit. Sorry. And destroy that. And that should be it. Destroying the line position is act as false. Destroying the linear velocity, destroying the orbit. Okay, that should be it for this function. And now we can plug it in down here. Game.replicated storage.stop power on server event connect, and then we can plug in our stop power. And yeah, we can see if this works. Might have to adjust the settings, but let's see. All right. Sorry, press E. And seems to be working. Might be too much. Let's adjust the settings, but it's working. So let's make the pull speed 1. We'll turn that down. Let's turn this down to 35. Orbit speed 25. That's good. That's good. The lift speed. Lift speed's all right. All right, let's test this out. Let's get a good snapshot. Yeah, that works pretty well. So we're making everything in the workspace lift up by holding E, and if we stop holding E, everything stops. So yeah, now we have ultimate power. I can control every part in the workspace with a click of a button. Yeah, that's gonna pretty much do it, guys. If you like the video, like, comment, subscribe, all that good stuff. And before we end it here, I actually want to go out a little bit further. Yeah, just to the player. Yeah, this is very fun. Um, yeah, I'll catch you guys in the next one. Peace.